Hey guys, welcome to the third installment of the Vectors Geometric Proof series. So today we're going to basically try to do two questions that are longer and much more intense than the ones we did in the previous video. So if you haven't already done so, please hit up the previous videos on the Vector Geometric Proof series. Give it a like, subscribe to the channel, tell your friends. So today, look, there's nothing really in the theory department that I need to sort of emphasize or go on to, just that these questions are worth quite a lot of marks. And I guess they're a big turnoff for a lot of students approaching this in an exam context because, well, it looks complicated, like with that sort of description in mind, let's move on. Let's check them out. So the first one is from Balcombe Hills in 2020. Now, let me just zoom out just to read through this question. So firstly, I guess before we dive in, look at this, 7 marks, right? We're talking a 3-unit paper, extension 1 paper, 7 marks out of 70 in total. That's 10% of the test all in one question. So if you can't do this, well, you're in trouble, right? So let's see. In the diagram, OABC and ODEF are 2 squares, okay, non-overlapping squares. W and X are the centers. Okay, that's a good start in the description. Points. Now, this is where it gets a bit complicated, right? Because it's not fully drawn in the diagram, so we might need to draw all over it. In fact, what I'm going to do to help me describe the workings that I'm going to do, I'm just going to copy and paste a few copies of these diagrams when I do it. So it doesn't matter if I draw over the original, I'll have fresh copies. Points Y and Z are the midpoints of the intervals of CD and AF respectively, good. And W, Y, X, Z are a parallelogram. So if I was to just illustrate that here, so we've got, sorry, I should have a tool that does, should use a tool to illustrate, but that's a parallelogram, right? That's what's been given in this guy here. And also then midpoints, okay, great. That's pretty important for later on. Midpoints of sides, okay, cool, of the quadrilateral A. So there is another quadrilateral, A, C, D. Let me just, I found that it was really hard to sort of describe this diagram without me drawing these in. So the parallelogram, the green parallelogram of W, Y, X, Z happens to be on all the midpoints of the bigger blue quadrilateral of A, C, D, F, right? All right, what else do we know? A, C, D, F have the vector. So we have, just to be ultra clear, we have O being the center there and all the vectors spawning from O. So for A, C, D, and F all have 2A, 2C, 2D, 2F as their position vectors. Cool. Now, this paragraph is basically quite important. Let's see. It can be shown that the interval joining the midpoint of 2 sides of a triangle is parallel to the third side and is half the length of the third side. You can use this. Now, let me just highlight that. There's a lot in here. So let me just draw you a diagram. It's actually really simple once you draw the diagram. Right? So it's saying, you can show that the interval joining the midpoint of 2 sides. So if I have 2 sides of a triangle, right? Let's say like that. If I draw the midpoints there and there, if I join them, it can be shown that that interval parallel to the third side is exactly half the length. So if these were parallel, right? Let's say this is A, B, C, D, E. Then that interval in the middle there is half the size of the third side. So basically in this case, BC equals to half DE, right? That's really what it's trying to say in paragraph word form, which, like I said, I've said this many times to my students. Ironically, the hardest part about maths tests and maths questions sometimes are the parts where there's no numbers, right? In this case, the numbers aren't there, it's just paragraph text. To glean that pink paragraph into this pink diagram, that's probably the hardest part. So there it is. Now, let's do the question, right? So that's just translating the descriptions of the questions into a diagram and our understanding. Let's go there now. So consider, okay, what's it saying? Consider triangle ACF. So where is that, right? So let me, I need to grab another color. I'm running out of colors. Actually, you know what? This is a good time to cut and paste a fresh copy of the diagram. I might make it smaller so I can actually, okay, let's see. And then put it here so I can actually look at. So consider ACF. Now, where's that AC? Okay. Let me move over a bit. ACF. So I'm just going to draw that ACF. This guy, and this guy out. Good. Express WZ, so this guy here, in terms of C and F. So now this is where we use that pink diagram above, because you can see if W and Z are the midpoints right now of, sorry, W is definitely the midpoint because it's the middle of the square. Z is the midpoint of that side. So we can use that formula upstairs. Find an expression for WZ in terms of C and F. Now I can sort of see, right? If I can find, using vectors, an expression for this guy, and I can find an expression for this guy, right? Which I can pretty easily do, can't I? Actually, no, I lie. Let's not do that. At the end of the day, I need an expression for this guy, right? So I already have this vector, which is 2C, and I've got this vector, which is 2F. I can easily get an expression for, sorry, there's a few colors involved here, I apologize. So let me just go. I can get pink from the two blues, and then I know that yellow in the middle is half of the pink. That's how I'm going to do it. And then similarly, it feels like I'll copy the diagram to do the next part. But let me just quickly do this, right? I'm just going to do it here, right? Let's just do it here, and I'll move it later on. So part one, I can see that CF, the pink one there, is equal to, now, it's going to be this blue going backwards, right? So it'll be, I'll write a CO plus OF. Sorry if there's a slight rumbling there, it's just my heater. It is freezing today in Sydney, so oops. So CO is negative 2C plus 2F. Yeah. Oh, it keeps going down. You know what? I have no more vertical space, so this might be a good time. Firstly, I'm going to move this guy into the question. Secondly, I will move this guy up here so I can work on it free of fear from running out of vertical space. So it feels like I should go therefore CF equals to, now maybe factorize to F minus C. Perfect. That's the pink. And then the yellow, therefore, right, using my theory down there, would be half of CF, which in this case will be half of that, therefore equals to F minus C. Yeah? Is that okay? Now, I think by the same token, if I copy this diagram, right? Now, what's the other one they want me to find? So similarly, find W. So maybe I'll do the same thing here. Just paste, put it right next door so I can actually just, so WY, where's that? So W, Y up here. So this is my yellow now up here. WY, A and D. So it'd be these two here. So it feels like I'm gonna need this guy here because that's the midpoint. That's the triangle that I'm really trying to. Where's the yellow? The triangle that I really want is that one there. And then I'm going to utilize the two blues like I did before of 2A there and 2D there, right? So I can express the pink in terms of the blues, and then the yellow is half of the pink, right? So by the same token here, and I'll just write it down here and I'll move it upstairs. So let's start with the pink. So the pink of AD is equal to, now it's going backwards, so it'll be AO plus OD, which in this case will be minus 2A plus 2D. So same thing, right? So let's factorize a 2 out, therefore AD equals to 2, factorize a D minus A. Yep. Pretty sweet, pretty easy. Therefore, now WY equals to 1/2. Equals to 1/2 AD, right? Why is it 1/2 again? Because a W is a midpoint of the square, and Y is given to be the midpoint of that interval CD. So therefore, oh, got that space. So let's do it again. Let's move that up here. Yeah, which equals to 1/2 of this guy, so D minus A. Perfect. Right? Tick, tick. Sorry, bear with me. Right. Okay. All right. Now, it looks like we've done a lot for 2 marks, but it's just me giving you the diagram so you can actually have a look, so you can visualize the answer, right? So now, part 2, that was fun. Part 1, triangle ADO and CFO. So let's make another copy of this guy so we can draw and scribble over so I can talk to it. Triangle ADO, where's that? ADO, yep, that triangle there, ADO, so ADO, this guy here. All right. It's congruent to triangle CFO, so maybe I'll just give it a different color, CFO. So okay, yep, I can sort of see that they are congruent. Yeah, 2 sides of the square and you know, angle in between. Perfect. By considering the lengths of AD, okay, and CF, okay, which are equal, show that WY and WZ are equal. Okay, where's well, WY is 1/2 of AD, and WZ, oh sorry, where's WZ? WZ is 1/2 of CF, so they must be equal, because if they're congruent, right, then AD would equal to CF, right? Corresponding sides of congruent triangles are equal, and therefore, because these guys are 1/2 piece of cake, okay, it seems like a pretty straightforward question. So once again, let me move this guy up here so I can do it. Pretty easy, right? So basically, it wants me to prove that this length here. So I'll use yellow again because I was using yellow for this. Prove that that guy, the magnitude of that is equal to the magnitude of that, right? And I know that that top yellow one is going to be 1/2 of AD, and that bottom yellow one is 1/2 of the pink CF. Because AD equals CF, and corresponding, I can conclude, right, that they're equal. Oh, I stole a therefore sign somewhere. Right? So I can start with saying, since triangle ADO is congruent to triangle CFO, right? That's given. Therefore, the magnitude, right, of AD equals to magnitude of CF. Right? And I can say, you know, if your teacher needs something, corresponding sides of congruent triangles are equal, right? Yeah, that's easy. Now, you know, the magnitude of the yellow WY is equal to 1/2 of the magnitude of AD, right? That's given, right, because it's 1/2. And the magnitude of WZ equals to 1/2 of the magnitude of CF, because they're equal. Therefore, magnitude of that is equal to the magnitude of WZ, right? One marker, right? Nothing too hard about that, hopefully. Now make a copy, whoops, make a copy. Let's do the next one. So what's to go here? Let angle C, okay, that's in the diagram as theta, good. All right, shown before, show that A dot F equals a negative, okay. Guys, dot products are involved, right? Whenever we have dot products involved, chances are we're going to use that relationship where cos theta equals to dot product over the magnitudes, right? So let's see what we're talking about here. So I got given, right, that COD is this guy, right? Okay. Looks like, right? Looks like I can use that formula that connects cos theta with the two sides here to get some sort of expression with dot products within D. Now, how do I get dot products with A and F? It feels like I know that this is a square that's right angled. This is a square that's right angled. Doesn't it make sense then that this angle here, right, angle sum of the point 90, 90, that's 180. This must be 180 minus theta, right? And then I can use this side and this side to get a dot product with this angle, right? And I think that works because then if I cos 180 minus theta, that's negative cos using my all stations central, right? Angles of any magnitude. And that's why you can see there A dot F equals a negative CD, right? Sort of everything sort of smells right, yeah? So let's proceed with that in mind. Now, I don't have enough space on this page, I reckon. So what I'm gonna do, I made a copy of the question. Let's do it like that. So to prove what I have to prove, so to prove that the A dot F equals a negative C dot D, I think I use the cos theta equals to dot product over the product of magnitudes in the green triangle and then the pink to actually do this. So let's do it like that. So for the green, right? So for the green, I can see, maybe I'll be very explicit, right? In triangle COD, right? I got cos theta equals to 2C dot 2D divided by 2C magnitude multiplied by 2D magnitude, right? You know what? I can simplify that. I definitely can, but I'm just going to leave it, right? For now, I'm just going to leave it. Because at the same time, in my pink triangle downstairs, in triangle, what's that? AOF, right? I've got cos of 180 degrees, sorry, 180 minus theta equals to 2A dot 2F over 2A times 2F magnitude, right? Now, I know, once again, just to be clear, using all stations as central or angles of any magnitude, this guy equals to negative cos theta. Okay, which means cos theta will be the negative case of this. So this is what I'm going to do, right? I'll go, therefore, this guy, 2C dot 2D over magnitudes of 2C times 2D should equal to the negative, right, of this one. Yeah. Now, at this point, what I really want is two things. One, the top numbers of 2 times 2. Oh, I'm missing a 2 there, right? Missing a 2 there for the F. And 2 and 2, they all cancel out nicely, right? Because they're just constants with the dot products, in which case you can sort of factorize a 4 out, right? They're all gone. I'm almost there, right? I can sort of see C dot D equals to A dot F. I need the bottoms to cancel out. Now, why does the bottom cancel out? What is the magnitude of 2C? That is the length of this guy, right? And I can see, because it's a square, the length of this equals to the length of this. In other words, magnitude of 2C is equal to that. And the magnitude of 2D is equal to that, right? Easy, 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 easy. I can sort of say, off to the side, since the magnitude of 2c equals to the magnitude of 2a, and the magnitude of 2d equals to the magnitude of 2f, right? Yeah, and I can write, just to make my teachers happy, equal sides of squares, or square, right? Therefore, 2c times 2d, right, multiplicatively, 2a, 2f are equal. Right? Therefore, these guys essentially cancel out, and I have, do I have any more vertical space? Yes, I do. Therefore, c dot d equals to negative. Oh, they want me to do it the other way around. So I'm just going to copy paste the negatives on the other side, right? So let's see. A dot f equals to negative c dot d, right? Done. So that was question part 3 for 2 marks. I feel like I've run out of space again, so I'm just going to copy this guy. Next slide. Fresh diagram. All right, let's do it. Last question. So by considering the dot products of wy, and okay, that was above. No, that wasn't above, yet to be done. As well as the results from 2 and 3 prove that w, okay, what we're seeing here, w, y, okay, the quadrilateral in the middle there is a square. Now, all we really need to do, if you think about it, right, we know it's a parallelogram, it's given to us. To prove it's a square, all I need to do, by considering the dot products, I say this to my students, whenever they talk about dot products, they talk about like angles, right? And in this case, for it to be a square specifically, I need to prove that this, so they're talking about wy and wz, they want me to prove that this is a right angle, that's all. If I can prove it's a right angle and it's a parallelogram, it has to be a square. What am I trying to say? They want me to prove that the dot product of wy and wz is 0. Yeah, by using everything above. So how do I do this? Put everything together. I've got an expression for wy and wz from part 1. I'm going to use that, right, in terms of AD, C, and F. Yeah. I've got some stuff up here, like this expression here, that might be useful. I've got magnitudes, everything might just work out. Let's have a look, right? Let's have a go. Now I need to go back to part 1 and get wz is f minus c and wy is d minus a, f minus c. Okay, let's write that down. Now, so this is part 4. From 1, wy equals to, so maybe I'll start with wz first. I think I did. Wz equals to f minus c, and wy equals to d minus a, right? Sweet. Now then the dot products, therefore, wz, right, this guy, dot product with above, wy equals to f minus c dot d minus a. Expand that and you sort of get like f dot d minus f a minus c d plus c a. Now, is it possible to use what I proved downstairs? So let's see, af, that's this guy, is equal to negative cd. Maybe we'll cancel stuff out. So using part 3, right? A dot f, so this guy here, that's the same as negative c dot. That's nice because then that and that cancels out, right? So if that's the case, this guy goes away with this, right? They're all gone because it's plus negative. So that just equals to f dot d, right, plus c dot a. Now, where can I see that? I can see, yeah, it's pretty easy, right? Now, what do I want? I want this to be 0. You can see, right? Individually, let's say this one here, f dot d. Where's that on the diagram now? Can you see, if this is a square, then this guy here must be a right angle, right? Must be. So then I know, based on this square here, that 2d dot 2f has to equal 0. Yeah, just by looking at this angle here. So then, yeah, therefore d dot f equals 0, right? Similarly, the other one as well, CNA equals 0 as well, because it's a right angle there. Same deal. So I'll say to my teacher over here, since O, what's the square? ODEF is a square, then 2D dot with 2F has to equal 0. Yeah, you can say all angles in square equal to 90 degrees, right? Therefore, D dot F is 0. Similarly, A dot C is also 0, right? Therefore, the dot product of that, right, which equals to F dot D plus C dot A is 0 plus 0, which is 0, right? Now, the grand finale up. You know what? I'll do the grand finale up here. Since, now what's the blue parallelogram? W, Y, X, Z, W, X. Well, actually, let's just conclude it. Therefore, angle YWZ is a right angle, right? Because the dot product is 0. Therefore, WYXZ is a square because parallelogram with right angle. Yeah. 7 marks. I mean, that was a bit long. 7 marks, 10% of a test. Now, extension 1 exams, it's 2 hours, 10%, 20 minutes. Should be about 20 minutes, maybe, give or take a little bit of time there, a few minutes either way. But yeah, it feels about right. There you go, guys. That was a harder question. Now, how long have we got? Probably, I want to do one more. Let's do one more. This one here is from, now, we know that the New South Wales syllabus only included vectors over the last 2-3 years, right? In the Victorian syllabus, they had vectors, well, you can see here all the way back to 2006. So if you want more past papers, definitely hit up the Victorian syllabus now. So from the iTube papers here, we have a diagram that says let OA be OC. Sorry, let me start up here. OM and ON, where are they? They are here and here, respectively, perpendicular bisectors, right? Perpendicular bisectors, right? So they're right angled and they bisect, right? Right angle and they bisect. Cool. And OP bisects, right? So OP at a minimum. We don't know it's right angled right now. We just know it bisects, right? Okay. OA, so let's go blue here. OA, where is it? Over here. Okay, it's actually in the diagram. That's A, OB, B, and OC. C. Yep, perfect. Express AC. Where's AC? AC, BC, BA. Okay, that's pretty easy, right? So guys, for part A, very quickly, Yeah, AC. Right, AC looks like it's between this one and this one, so it would be backwards of A. Let's see, so it'd be C minus A. BC, which is this one, so it'll be C going backwards up here. So BC would be B minus C. And where's the last one? BA going down this way. So A is positive, B is negative. So BA equals A minus B. Right, 1 mark. Nothing too hard about that. Now, express OM. Okay, cool. So I need to now find this vector in the middle here, right? In terms of ABC. The way I'm going to do it, there's a few ways to do this, but the way I'm going to use the fact that it's a perpendicular bisector, right? So if I extended this guy out, right, to be a perpendicular bisector, what that means is that essentially, if I extended it there, right, the blue is a parallelogram. The middle there is half the diagonal, right? Half in the middle, right? It's a bisector. Yeah, half the diagonal, right? Bang smack in the middle, right? Because it doesn't really say prove, I know it's in the middle of a parallelogram, so therefore I know it's going to be half of the sum, right? Because I know the one in the middle here, right? The full length here, this guy would be B plus C. It's a full length, yeah? And so if it's half, I can conclude, right? Therefore, OM is equal to half of B plus C. And just working around, right? ON is a half of these two vectors, A plus C. And by the same token, OP is equal to a half A plus B, all right? Nothing too fancy about the part A and part B, right? Let's see where it's taking us. Hence, show that the magnitudes of A, B, C are all equal, right? So basically, O is what they call the centroid, right, of the triangle. Okay. Now, the best way to do it, let's have a look. Now, I haven't used anything with the right angles yet. Maybe I should do that. So if this is a right angle, OM, which they got me to find, and BC, okay, I must be using this, right? So let's connect them. Since it's a right angle, OM, this guy, and BC, this guy, right, have a dot product of 0. So since OM is perpendicular to BC, right, I have OM as a vector dot product with BC to be 0, right? Therefore, half B plus C dot B minus C equals 0. Half goes away, right? Therefore, difference of 2 squares. So B dot B minus C dot C is 0. We know that means a magnitude squared minus magnitude squared is 0. Therefore, magnitude of B equals C, firstly. Now, if I could do the same using the bottom two, A and B, if magnitude of A equals to B, then A, B, C are all equal, right? Has to be. So what I'm going to do, I think we can say similarly, right? Yeah, let's do it. Yeah, similarly, right? Since ON is perpendicular to AC, right? I'm just going to conclude, right? A should equal to B as well, right? Therefore, A, B, C are all equal. So I'm doing this with a bit of patience. Just look at the marks, 10 marks, Jesus, right? Because the start of this question is actually much easier than the other one. Less text, more diagrams, right? So that part there, done. Prove that OP is perpendicular. Okay, cool. So the third side, for some reason, wasn't given that this was a right angle. Now we have to prove it, right? The two other ones were perpendicular. This one wasn't. So all I got to do is show that the dot product of those two are equal. Equals 0. Right? That's really what I want to do now. So, I've got heaps of vertical space. Love it. Love it. Love it. Love it. Okay, let's see. So this was part 1. Let's do part 2. So in this case, right, all it's really asking me to do, right, is basically show that OP dot product with BA equals 0. That's absolutely key. All right. So let's do it. In this case, I've got expressions for OP. I've got expressions for BA. Yeah, let's sub it in. OP was a half. I can see it up there now. A dot plus B. Oh, wait a second. I proved for this similarly one. I used the wrong ones because ON is A and C. Okay, cool. Let me just quickly change it. Not that it changes any of the conclusions. All that changes that becomes a C. Right. Okay, cool. So on this one down here. So that dot product with BA, quickly scan. BA is A minus B. Good, good. Exactly what I want. Once again, expanding that'd just be a half A dot A minus B dot B, unsurprisingly, which is a half of the magnitude of A squared minus magnitude of B squared. And since A equals B, this equals 0, right? Which equals 0. Therefore, OP is perpendicular to BA. Piece of cake, right? That's 7 marks already. So that 7 marks is so much less intense than the other 7 marks in Bolton Hill's question, right? But now it's led us to the final part. Show that, Jesus Christ, look at this monster of an expression, right? Right, and it's got a letter D there. So let me zoom in, I can't see it. It's got a little D there, which equals to this, right? Okay. So D equals to, okay, it just equals in magnitudes. All right, cool. So it looks like we're going to factorize it now. Guys, it's got cos alpha, beta. What's alpha, beta, gamma? Alpha, beta, gamma are the angles between AB. Okay, cool. Once again, can I ask a favor? I am going to take a fresh copy of this question because I need a fresh diagram to draw in things. But it looks like we're going to just use the cos theta equals to dot product over product of magnitudes 3 times, and then sort of add them. Yeah, add them through. So let's see where that takes us. So I think I made a copy. I didn't. Okay, well, here you go. So let me just copy that through. Just remove all my workings. Get that gone. Perfect. Clean. So in the diagram, let's see, alpha is AB. So AB is over here, so that guy there. Alpha, it matters, I think. Beta is between B and C. Beta and gamma is over here. Cool. So let's just test it, right? Let's test the theory. So for part D, I'll move it over, right? Right now it's just over here. In the first triangle here, right? In the first triangle here between AB and alpha, right? AB and alpha. I've got cos alpha equals to A dot B all over A B, right? Okay, now that doesn't look very useful, but what I do know, let's see. What I do know is I'm gonna, oh, that's right. Because it's telling me, right? It's telling me to use AC magnitude. I'm just going to use cosine rule. Maybe I've used the wrong thing. Maybe you use the wrong thing. Maybe I'm using cosine rule. Because I haven't actually got in my diagram AC. AC is this guy, right? Oh, okay. Maybe I'll do BA first. I'll do BA first. Yeah, which is this guy. Yeah, I just use cosine rule. Perfect. Yeah. So ignore this bit here. Got too excited with the angles, right? Let's just use cosine rule where the magnitude of BA squared, same thing, the cos pops up again, equals to magnitude of 2 pinks. So that's like A squared plus B squared minus 2 AB cos alpha. Now, this is why for every time you see one of these magnitudes of A, B, they want you to replace it all with D's, right? That's D, 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 and D, right? So then that's quite clean because then it becomes like 2D squares minus 2D squares times cos alpha. I would think that I would try to factorize to get 1 minus cos alpha. All right. Now, let me see. If I do this 3 times, then I add them, I can factorize every, perfect, it'll work, right? Super easy, all right? So with this, super easy. So, therefore, BA squared equals that. Yeah. Now, I'm going to do it 3 times similarly. Now, let's just get the order, all right? So BA was this one. AC would be between A and C. Okay, cool. So then, oops. Magnitude of AC vector would equal to, once again, 2D squared. That'd be 1 minus cos gamma. And what was the last side? BC, is it? Yep, BC. And magnitude of BC equals to 2D squared. Similarly, 1 minus cos beta. Yeah, so you have 1, 2, 3, and you just add them, right? Just add all left and right hand side. So therefore, I'll put it in the order that they have downstairs. AC, sorry, that's a squared, right? Vector squared, magnitude squared, this guy squared, this guy squared equals to something now. Sum and factorize, so it'll be 2D squared. Factorize, it'll be 1 minus cos alpha plus 1 minus cos beta plus 1 minus cos gamma, which then equals to 2D squared 3 minus, now they factorize this, cos alpha beta gamma added. Done. So I guess this question wasn't hard in terms of its intensity, right? It was, I guess it's more harder in terms of the fact that there are multiple parts that require you to, have a certain approach to each one and then use the parts above to do it. Guys, hopefully that was a good sort of lesson for you to see, it steers away from the easier questions of geometric proofs that simply prove 1 or 2 with 1 or 2 steps. These ones are multi-step, many marks, a good question to have near the end of an extension 1 paper. So if you like that series on geometric proofs with vectors, please give the video a like, subscribe to the channel and tell your friends. Otherwise, I'll see you guys at the next lesson.